Hello students, good day. Topic for today, we have the graphing of linear equation. So first, here's our learning competency. Graph linear equation given any 2 points, the x and y intercepts, the slope, and a point on the line. So first, here's our unpacked learning competency, is to graph a linear equation given a 2 point, x, y intercepts, and slope and a point on the line. Now, here's the linear equation. A linear equation in two variables can be written either in the form ax plus by is equals to c or y is equals to mx plus b, where a, b, and c are real numbers and a and b are not equal to 0. Then, graphing linear equation can be done using any of the three methods. First, using the 2 points. Second, the x and y intercepts. And lastly, slope and a point. Now, let's try to identify first using 2 points. Using 2 points, we have one method of graphing a linear equation is using any 2 points. Remember that 2 points are enough to draw the graph for a linear equation. So we have the line postulate, 2 points determine a line. Now let's try to have an example. Example number 1 says graph the linear equation y is equals to 2x minus 3. Then, here's our solution. You may assign any two arbitrary values of x, say 0 and 1, and then solve for the corresponding value of y. So first, by substitution, we have 0, y is equals to 2x minus 3, so y multiplied by 0 is, y 2 multiplied by 0 is equal to 3, so y is equals to 0 minus 3, then y is equals to negative 3. When x is equal to 1, we have 2 multiplied by 1 minus 3, or 2 minus 3, we have y is equals to negative 1. Therefore, here's the illustration. We know that 1 and negative 1 and 0 negative 3. So the solution shows that if x is equals to 0, then y is equal to negative 3. Also, if x is equals to 1, then y is equals to negative 1. Thus, the ordered pair are 0 and negative 3, and 1 and negative 1 respectively. This means that the line passes through these points. Now, let's have another example. Graph the equation that passes through the given pair of points 2, and 4, 5. Now, here's the graph. We have 2, 2, and 4, and 5. Using the line postulate, 2 points create a line. Now, we're proceeding with using x and y intercepts. So, using any x and y intercept, another way of graphing a linear equation in two variables is by using the x-intercept as a and y-intercept as b. The x and y intercepts of the line could represent 2 points, which are a and 0 and 0b. Now let's try to have an example. Graph the linear equation y is equals to 2x minus 3. So we will have the solution. To find the x-intercept of the line, given its equation, let y is equal to 0, then solve for x. So here it is. To find the y-intercept, let x is 0, then solve for y. Letting y is equals to 0, the equation y is equal to 2x minus 3 becomes, first, 0 is equals to 2x minus 3. By how? By substitution. Next, 0 plus the quantity of negative 2x is equal to 2x minus 3 plus the quantity of negative 2x. How come? Using the inverse property for addition. Then we have 0 minus 2x is equals to 2x minus 3 minus 2x. Distributive property. And next step is to 0 minus 2x is equals to 2x minus 3. Associative property for addition. Then 0 minus 2x is equals to 0 minus 3. We just simplify. And negative 2x is equals to negative 3 are the identity property for addition. So 0 minus 2x, we have negative 2x. 0 minus 3, we have negative 3. And for the next step, we have 1 half multiplied by negative 2x is equal to 1 half multiplied by negative 3. So we will have, we use that by the inverse property for multiplication. So next we have negative x is equals to negative 3 all over 2. So we just simplify the quantities. Then negative 1 multiplied by negative x is equals to negative 1 multiplied by negative 3 all over 2. Multiplication property. Then lastly, we have x is equal to 3 all over 2. So hence, the x-intercept is 3 all over 2 and symbol A is equal to 3 all over 2. Then the point in the x-axis is 3 all over 2 and 0. Next, to find the y-intercept, let x is equals to 0, then solve for y. Letting x is equals to 0, y is equals to 2x minus 3 becomes y is equals to 2 multiplied by 0 minus 3. Substitution. Then y is equals to 0 minus 3, identity property for addition. And next, y is equal to negative 3. Hence, y-intercept is negative 3 in symbol B is equal to negative 3. Then the point in the y-axis is 0 and negative 3. Here's our illustration. So here's the graph. You will see we have 0 and negative 3 and 0 and 3 all over 2. The x-intercept A is 3 all over 2 while the y-intercept B is equals to negative 3. Now, for the other example, we have graph each linear equation whose x-intercept A and y-intercept B are given below. A is equals to negative 2 and B is equal to negative 4. So here's our illustration. We have 0, negative 2 and 0, negative 4. It's just simple. See? Next, we are using slope and a point. Here, in using a slope and a point, graphing linear equation can also be done using the slope and a point. How? Here's an example. Graph the linear equation whose slope is 2 and contains the points negative 1 and negative 5. Here's the solution. Plot the given point negative 1 and negative 5. Then use the formula m is equals to rise all over run to identify the rise and the run. The slope of the line is 2, which is equal to 2 all over 1. Starting the given point, negative 1, negative 5, count out the mark, count out the rise 2 units up and run 1 unit to the right to mark the second point. Note that the slope is positive. So draw a line passing the points. So let's try to have, here it is. You will see first negative 1 and 5. Then we rise up 2 times, 1, 2. So we go to negative 3. Then going right, so we have 0. So our B there is 0 and negative 3. Now to make it clear, let's try to have another example. Example, the graph line whose slope is 2 and contains the point 3 and 1. Now we're proceeding with the illustration. So here's our illustration. First, plot the given point, 3 and 1. Then next, we have the slope of 2, rise, 1, 2, going 3, the y. Then rise, going right, we do a run, going right, we have 4. So the point B, or the y-intercept, we have 4, 3. It's that simple, and we are now done. Thank you for listening and see you in the video conference. Thank you and bye.